electrical class. Today we are going to talk about series and parallel. How important are the series and parallel circuits, and how necessary are in this particular business, the marine business. Okay, what happens when I connect, for example, those 4 lights are in series, and those 4 are in series, and the other ones over there in series, and each series is connected in parallel with the other one. This is a great design. No, this is exactly the same as in the saloon of the boats. You have normally 3 lines. Each line is series. What happened in this series if this light bulb is broken?
The rest after go off?
The rest of this line is off. This is the inconvenience. No? But I have other 2 lines over there. No, that's good. In some boats, they design like this. This is a series DC current. The last one over there, other series DC, and the middle one is other series AC. Okay. If this is broken and the last one is broken, but the generator is running, I have lights in the middle. It's a good combination, no? All right. That's the inconvenience when I have series. If one is broken in the series, the rest are broken, because the current no pass. This is the good example of that situation is in the Christmas lights. You remember? Yeah. If one light is broken, what happened with the rest of the series? No, finito. And try to find which one is broken.
Usually just get thrown away.
Exactly. Put on the garbage and replace. All right. But what is one of advantage of there are a lot of advantage of series, but the most important, one of the most important, the intensity in all of them is the same. The intensity of the light is equal. This is good, no? All right. Other thing is if I want to design circuits with a self-protection, those circuits in series are excellent. For example, think in the harness of the engine. The harness of the engine is a bundle of a lot of cables, and in that bundle, suddenly one cable goes out for the oxygen sensor. Continue the bundle, and other cable goes out for a throttle position sensor. And continue the bundle, and other cable goes out for a start motor. And yeah, a lot of, but all of them in the same backbone. Okay, what happened if the second sensor, oil pressure, sends low pressure in the oil? Immediately the sensor open, activate the computer, and turn off the engine, because it's in series. This is a good advantage. If the temperature, the sensor number 3, sense problems with the temperature, kill the engine. This is the advantage when you connect in series in circuit where you need this protection. This is a good idea. No? We are going to find a lot of circuits in series. For example, the fire suppression system. If the fire suppression system is activated in the engine room for some reasons, immediately shut down engines, shut down generators, shut down everything, but protect, no? Because it's the cable to activate the cylinder, the bottle of the extinguisher, is in series with the main power of the boat. If the extinguisher is activated, the main power, turn off. Good. Okay, series. What I need to create a circuit? I need the power, the load, excuse me, the source of power. I need wires. I need fuses to protect. I need interrupter switches, and I need loads, the fan, the motor, and I need more cables to return into the negative. Once again, the circuit is, I start from the positive, but I return from the negative. If I don't return, what happens? Nothing. You try to start, you try to turn on. This is the most common problem in circuits. Hey, my friend, What is your problem? No, I don't know, Mr. Lopez, but it's okay. Check the circuit. Where is connected the ground? Oh, sorry, no ground. Oh, yeah. Or the ground is loose. Or the ground is corroded. The ground is the negative. It's the return in DC. That's okay? Other common issue is, I don't know, Mr. Lopez, but right now, my engine or my generator start if I go to the engine room and I start directly over there. But here in the flybridge, nothing. What is the problem in that case? The negative of that group of batteries is disconnected. Hey, my friend, you did something in the battery banks recently? Oh, yesterday one guy replaced 2 batteries in the house battery bank. Oh, okay, my friend. Can you put the camera, go over there? Can you show to me the output positive and the output negative of that series parallel? Yes, this is the positive and here is the negative, Mr. Lopez. Hey, my friend, you see that black cable in the bottom of the box hanging? That's very, very common. Very common. All right? Good. We are going to create a simple circuit. We are going to use symbols, no? In DC, the symbol for battery is like this. No? And this one, this plate, the last one, the small ones here, are the positives. Okay, from the positive, start the first wire, and the first wire is positive, is red one. And we are going to install the first element. Always, 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 we need fuses. Now we are going to talk about the capacity of the fuse. How I select the fuse? It's according with the load. Okay, I have a fuse here, and I continue with my positive. And I am going to install a switch or interrupter. And after the switch, I can install the load. For example, I am going to install a light bulb. This is the light. This is the light, guys. No? And we are going to return. Simple. That's the return. And the return, my friend, is returning to the negative side. And this one, guys, this point of return is connected to the ground. The negative is always connected to the ground. This is why you say in DC, oh, your ground. But really, of course, because the ground bus bar, the negative bus bar, at the end of the day, will be connected with a green cable in the bonding conductor and connected to the sink. That's the most important part. The negative bus bar. How many negative bus bar I have in this boat? 1, 2, 3. 1, 2, and other here 3. Oh, 3. This one is in the DC panel. This one is in the fly bridge. Oh, I have, no, this one no. This one is on the fly bridge, and this one in the main engine room. Probably there are in about 20 in the cabin. Here. Different. All of them are together. All of them should be connected together. And this one connected together. All of them. And this one finally with the battery in the other side. If not, I don't have power in any part of the boat. Good? Okay, I am going to create one circuit here. Look, it's nice. The battery. This particular battery is 9 volts. 9 volts. I am going to do that circuit. I am going to connect the wire number 1. After that, I am going to install a fuse. After that, other wire. After that, the switch. After that, the light bulb, no? I have the light bulb here. After that, another wire. And bingo, I have my circuit. All right, and look at this. I have the flow of charge, and I have the light, or I have the flow of electricity. You remember? In the opposite direction. Nice, no? Okay, this circuit is a simple circuit. I am going to modify a little this circuit. Okay, we are going to install another light bulb. And how is the connection in between the negative of this with the positive? I put the cross cable, you remember yesterday in the batteries, in a different color to avoid that the people try to use that point. And after that, from the negative, I return. What is the name of that circuit? It's series. It's series. Because I connect the negative of this with the positive of this and the negative of this with the return. Yeah? It's in series. Exactly the same like when you connect two batteries in series. Let me modify this one a little. And we are going to introduce another light bulb. Another light bulb here, and we are going to install another cable here. And I have a series. Yeah, guys? I have a series. And once again, if I close the switch, I have in series those L. Okay. Look at this. This is the total voltage. It's 9 volts. Okay? Here in the point number 1, I have a voltage number 1, intensity number 1, and resistor number 1. In point number 2, you remember? Exactly. Voltage number 2, intensity number 2, and resistor number 2. We are going to solve it today, circuits. And I am going to explain the process to solve the circuit easily. If you create a simple table, and in the table you fill the values of V1, R1, R1, intensity 1, yeah? Okay. This is the total. And here we have total intensity, and we have a total resistance. Okay, what happened in a series circuit like this with the voltage? The total voltage, what happened when you connect batteries in series with the voltage? Go up, no? Is equal to voltage 1 plus voltage 2 plus voltage 3, and it's going up, depending how many elements I connect in series. What happened in a series circuit, guys, with the intensity in series? It's the same. The total intensity is equal to intensity 1, intensity 2, intensity 3, is the same, is constant. Perfect. And what about the resistance? The resistance in a series circuit goes up. The total resistor is equal to resistor number 1 plus resistor number 2 plus resistor number 3, increase. Oh, nice. Oh, nice. Okay. That's great. Let me check if it's true that the intensity is the same in any part. I have an ammeter. I am going to use my ammeter. I am going to close the circuit. Let me check the intensity here. 0.45 amps. Let me check the intensity here. 0.45. Let me check the intensity in between both loads. Let me check the intensity in the up. Let me check the intensity before return to the negative. Oh, is the same. It's the same. The intensity is constant. What about the voltage? The total voltage is equal to this plus this. Oh, let me check that. This is intensity. And we are going to play with the voltmeter. Now with the voltmeter. Okay, with the voltmeter, I am going to connect here the negative. And how much will be the voltage here in this point? It's 8.99. Here is 9. but over there is 8.99 because I have loss of power, voltage drop, because the cable, because yeah, some drag. Okay, what about the voltage here? 4.5 volts. In the voltage number 1 is half, because the resistance in both lights bulbs is the same. What about the voltage here?
0.
Because this is the negative terminal. In the positive terminal. 4.5. Okay, let me check how much is the voltage here exclusively in the second one. Other 4.5. Other 4.5 in this. Yeah, 4.5 plus 4.5 is 9. Perfect. That's true. That's true. You like that? It's nice, huh? Okay, this is in series. Let me try to do another circuit in parallel. Once again, I have the fuse, and I have the switch, and after the switch, I am going to install one light bulb here, and another light bulb here, and after that, this is the negative, and I return to here. This is parallel, no? I have one light bulb here and the other light bulb here. What is the advantage of parallel? What happens if this light bulb is broken?
Still works.
I have another path. This is good. Can I connect 3 light bulbs? Yes. Let me do another one. Okay, I have here the switch, and let me modify a little here. Let me bring one of those light bulbs. No, excuse me. Let me reduce this diameter a little, and I am going to enter here. I am going to create another part here, and I am going to install one light bulb here, and I am going to install another light bulb here. I'm going to install 3. 3. And I am going to install another light bulb here. And the negatives, all the negatives converge in a common point. Everybody follow me? Right? And this one with this, and this one with this, and this one here, and another wire here, and bingo, finito. It's parallel, no? If I close here, bingo, nice, I have power over there. This is the flow of charge, and this is the flow of electrons, or vice versa. Wow, nice. Okay, good. Let me analyze what happened in parallel. This is the total voltage. This is voltage number 1. This is voltage number 2. Intensity number 2. Yeah. In each point, exactly the same. Okay. In parallel, this is parallel, and this is series. In parallel, what happened with the total voltage when you connect in parallel? It's the same. It's the same. You remember the batteries yesterday? This is equal. What happens if I connect 20 batteries? 20 batteries is 12, 12, 12, 12, 12. Yeah, depending how many batteries you connect. The voltage is is constant. What about the intensity? Intensity in parallel?
Go up.
Go up. Oh, wow. Yeah? Goes up, the intensity. This is the difficult part. What about the resistor? The resistor, the total resistor is equal to the opposite of when you added this plus this. Yeah? Now we are going to analyze what happened with the resistor. We are going to do an example with three. For example, this one. Suppose that the resistor number 1 is 5 ohms. Resistor number 1 is 5 ohms. And resistor number 2 is 10 ohms. How much is the total resistance
50.
in that circuit? Pay attention. 1 divided by the total resistor is equal to 1 divided by 5 plus 1 divided by 10. We are going to refresh kindergarten. Okay. What is the less common denominator here? What is the number that accept this or accept this? 10. Okay. 10 into 5? 2. Times 1? 2. 10 into 10? 1. Times 1? 1. This is kindergarten. This is the last time that I repeat that. Is 3 divided by 10? Look at this. Look at this. It's equal to 3 divided by 10. RT is equal to 10 divided by 3 is 3.33. Yes or no? Because I flip. No, but it's kindergarten. In the daycare, you learn that. Okay. Look at this. This is the total resistance is 3.3. How much is the value of resistor number 1? 5. And resistor number 2?
10.
Oh, in parallel, the total resistance is less than the smaller resistor in the parallel. Wow, this is great. I reduce the resistance in parallel. The total resistance is less than any of the resistors individual. Wow, this is great. This is very important because in some circuit the problem is the resistance, too much resistance. Parallel, you avoid that inconvenience. The total decrease. Okay, great. Let me verify, for example, that it is true that the voltage is constant. We are going to use the voltmeter. The voltmeter. And let me put the voltmeter here. And let me use, okay, I put this one here. And we are going to check the voltage in the first one here. Of course. I need the close. It's 9 volts, 8.96, no? What about the voltage in the second one? What about the voltage in the third one? It's constant, no? Can I put the negative here in this point and I check the voltage here? Yes. And here? Yes. And here? Yes. You see? Because this side is the negatives. And this side is the positives. Everybody follow me? Alright, the voltage is constant. The voltage is constant. But the intensity goes up. Oh, okay. Let me check. Not with the voltmeter. With the ammeter. Let me use the ammeter. Let me bring the ammeter. And I am going to check the intensity here. 2.69. Let me check the intensity after the first one. 0.9. In the second one, in the output of the second one, the intensity 0.9. In the output of the third one, 0.9. How much is 0.9 plus 0.9 plus 0.9? Excuse me? 2.7. How much is the intensity here? 2.7. Bingo.